Can you tell us a bit about yourself and your background, please?
Sure thing, yeah. So I'm Commercialisation Manager offshore renewable energy Catapult, and I've been with the Catapult for about 4 or 5 years now. But as Commercialisation Manager, my role is to work with companies who are potentially bringing new technologies into the offshore renewables sector. So, I'm basically looking for the next great ideas that are going to make a difference in terms of reducing the costs in the sector and potentially, creating new business opportunities and services within the UK supply chain. So, within my role, I'm spend a lot of time working with companies with new ideas. So I'm exposed to a lot of things. Prior to this role, I was in the commercial team at Catapult, and we've got £150 million worth of test assets down in our centre down in Blyth, and my role was to work with the world's leading technology developers to prove and demonstrate their technologies down in those assets. So I was seeing a lot of new technologies coming through. We had a set of subsea test facilities, so I saw a lot of the new trenching equipment and ROVs coming through and being tested there, and also looking at new turbine designs and blades and drivetrain systems that were also coming through those facilities.
What do you think is needed for the next generation of technologies are needed?
So wind is going through an interesting phase at the moment. We've had a decent amount of installed capacity. It's now been operational for quite some time. And what we're finding is that some of those, a good proportion of those turbines are coming out of their 5-year warranties. And this changes the game in terms of opportunities for companies developing technologies coming into the sector, because originally you had the turbine OEM who would be handling that service contract, and now that's going to independent service providers, that's going to the operators themselves, and then sometimes it's being retained by the OEM. So this is quite an active space for new supply chain companies getting in. And once you get to that point where a turbine comes out of warranty, there's a huge driver for the asset operator to understand exactly what's happening on their wind farm, because they'll want to know when a component's going to fail, when they need to do any remediation work to prevent their turbines being shut down and losing revenue through lost generation. So there is a huge driver at the moment in O&M to increase the amount of information, increase the knowledge that we are getting from the various assets within the offshore wind farm. So the way that can be done is through
inspection, data, monitoring, those sorts of...
Exactly, yeah. And so it's a space that's ripe for innovation. So one of the areas where you can see huge opportunities in terms of technologies coming through in Subsea is autonomous and also remote sensing technologies. So this can be on the jacket structure, this can be on the cables as well, and they send out an ROV with a vessel pretty much every year to go and do a survey of these assets to make sure everything's in order, that the cable's still where it should be. But if you so that's a vessel, that's an ROV, that's a team of technicians. So there's significant cost involved in there. So if you could develop an autonomous solution, potentially that had residency on the wind farm, so it lives out there. It could be deployed from the substation or some docking station somewhere within the wind farm. It could then fly out of its own accord, do the survey, come back, transmit all its data and recharge its batteries, go out, do another survey, and you eliminate the vessel. And one of the major costs in O&M for offshore wind is vessel cost, fuel costs, and technician costs. And so operators are looking for any way that they can reduce all three of those. And by bringing autonomous solutions, that's one of the key ways that they see that as making it possible. Moving beyond just the data collection, but also post-processing of data is extremely time-consuming for those back in the control centres. So if you had autonomous signal recognition from say there was a potential fault, then that data could from a live feed or when it goes back to its docking station, you would be able to see instantly that there was something where a decision had to be made, rather than the data being sent back. Lots of people analysing it and post-processing it. If it can pick up on certain failure modes or signatures that it spots, then you can make the decision-making process much quicker, and the problem can be alleviated much quicker, which is what they want. They don't want to be fixing it after it's broken. They want to be fixing it before it's broken. Cables are, and they're going to become increasingly important because we've gone from 33 kV for inter-array cables to 66 kV. So the importance of that asset has gone up. It's doubled because that's your revenue going back to the substation. That's your revenue going back to shore. That's your money essentially. And it's all well and good having turbines turning, but if you can't export the power, what's the point? So one of the big drivers is to increase the capacity of cables because then your cost is reduced through the you install fewer number of cables because more power is being exported through one. But then that comes with its own risks because if the cable fails,
fewer of them, yeah.
So you've got two drivers in that technology theme. One is to increase cable capacity and to improve things like cable protection systems and connectors as well, but then also to improve the monitoring of those cables throughout the installation process. So when the cable's coming off the back of a vessel and touching down onto the seabed, how is that monitored? Because you can't monitor the cable effectively with current technologies until it's fully connected, because then you've got the fibre optic within the cable that can be used. Yeah, you can get distributed strain sensing, but prior to that point, a lot of it's done through visual inspection. You don't know if the cable is going over its maximum bend radius during installation, or whether it's being put under too much strain as it's being pulled into the turbine, etc. So there's quite a lot that can be done on condition monitoring in that space. In order to reduce costs in offshore wind, which is the biggest driver, the turbines are increasing in size. We've gone from 2 megawatts back in 2001, whenever it was, and right through to we're now looking at installing 8.2 and potentially beyond that. And there are designs for 10 and 12 megawatt turbines. And each time we've gone up a few megawatts, the cost reduction impact. Structure gets bigger, but then there's less infrastructure. So you've got less turbines in a farm. So you're installing a fewer number, even though they are bigger, and you've got fewer cables to trench and install. So your capex reduces quite significantly. That if you can build a turbine of that size in a cost-effective way. And this has a knock-on effect, obviously, in the foundations and substructures, because obviously bigger turbine means bigger foundation. And so one of the key pieces of work that's going on in the industry at the moment is to try and identify areas for cost reduction in the design of foundations and substructures. So if you could come up with a subsea technology that was a low cost, perhaps again looking at resonance systems that just go around a jacket structure and continually clean, and keep it completely marine growth free, then you could look at reducing capex costs of foundations, which all of a sudden becomes very interesting to the operators and the developers of these sites.
Good. Okay. Andrew, thank you very much for speaking to us.
No problem.
Cheers.